somebody turn on everything except the one that says whiteboard up there? I think there's only one that's. Can somebody flip the switch? I think it's the in. I can't remember. Yeah, not that one. Sorry. Yeah, everything except that one. Yes. Yeah. There. Okay. Sorry, buddy. It's on my whiteboard, so I can't. It's the glare. So I'm not the biggest fan of the order they did things in, but I'll work with it in the book. So remember in algebra, when I ask you about slope, what type of thing am I talking about? When you said slope of something, that was slope of a line, because that's the only thing you can handle at that stage. The minute you have something that's not a line, what's happening to the slope? It's constantly changing. So the slope of a line is a constant function because that's the definition of a line. It's always going in the same direction. If I ask about the slope of any other kind of function, the answer is going to be a non-constant function. Oh, shit. So for example, if I have a problem, right, and I'm curious about the slope at 1. Right, I want to know the slope at 1. I want to know the slope of a tangent line at 1. And a tangent line is, for example, if I was swinging something around my head, it would make the shape of a circle. And if I let go of it, it's going to fly off in the direction tangent to where it was going at that moment. So if it's in a circle, wee-haw, wee-haw, wee-haw. And if I let go right here, it's going to fly off that way. Right? That makes sense. I like it. I like it. That's the idea of a tangent line. It's like at that instant, make a straight line with that slope. That's a tangent line. So what we're trying to do at first is figure out this line right there that touches it right there once. What is its slope? Now, there's a fundamental issue with that question. In algebra, or in general, how do you find the slope of a line? You need to have how many points? Oh shit. I want to know the slope at that point. That kind of starts off in a bad place. You're like, okay, slope, I could do slope, 2 points. You want the slope at that 1 point. Shit, right? What do I do? So one thing we do is sort of related to, this is where you can see that idea of a limit coming in, is I do the slope between 2 points. For example, like this one. Yeah. Got it. Now that is going to be like a really rough estimate. Because what's happening to the slope as I go around this corner and keep going? What's happening to the slope? It's getting, well, what's happening to the slope as I turn this corner? What's happening to the slope? It's getting, what's the slope right here? At the bottom, the slope is 0. What's the slope back here? Negative. So what's happening as I turn the corner? It's positive, getting bigger positive. You guys, because it's going up, high, faster, faster, faster. Maybe. So this is called a secant line. Notice the relationship between trigonometry and these words we're using. Later in this course, we'll see the connection. So when I do 2 points off of a function and find the slope between those as an estimate for a tangent line, that is called a secant line. Secant line goes through 2 points. Tangent line is the one going through that 1 point. That's our goal. So take a minute and figure out the slope between these 2 points. Well, take several seconds. What's the slope? Let's call it P. Yeah. 4 minus 1 over 2 minus 1. 3. Now how do I improve my estimate? How do I make my estimate better? Remember, what am I trying to estimate? The slope at 1, 1. I wanted a slope at this point. So we're trying to estimate slope at 1, 1. Our algebraic minds go, shit, I need 2 points. This point was a nice point, came out with nice numbers, but it sucks because it's so relatively far away. Some people might say it's not very far away. I'd say, well, it's an infinite distance away. So, potato, potato. So what's one way to make this better is to do what? Get closer. So instead of using 2 as an input, what can I use? Yeah, I like it. Let's just go right to 1.1. So now I'm going to have, my points are going to be 1.1 comma 1.21. So it's 1.1 squared, right? So now I want to do the slope between P and Q1. So now I've got what points? 1, 1, and this is the point 1.1. Is everybody cool with where 1.21 came from? Because what function is that sitting on? It's x squared. 1.1 squared is 1.21. So what's the slope between those two now? Yeah, so it'll be 0.21 divided by 0.1. 2.1. How are we doing so far? All right. Do one more step yourself. Make a better estimate. See, this is not good. I don't know what you guys are going to pick. I'll think you pick a certain thing, but we'll see. So, the natural choice for the next thing to use, I would think, would be 1.01. That makes sense. Now, if you didn't use 1.01, you're fine, as long as you're getting closer to 1. And of course, what's 1.01 squared? To 0.0199 minus plus 1 point. I'm trying to do this in my head. It's really freaking me out. You guys, anybody have a calculator? Yes. 1.0201. Is that right? Yeah. Real quick. If I want to do 1.01 squared, I could do 1 plus 0.01, so it's 1 plus 0.01. FOIL, add. That's what I was trying to do in my head. I couldn't keep track of a couple things. It's early. I didn't have enough caffeine. And then what's the slope going to be between those two? It's going to be 0.0201 divided by 0.01. Is that cool? The difference between those? So that's going to be chunk, 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 2.01. Can you hazard a guess as to what the slope is at 1, 1? I would bet a lot of money that it's 2, right? Can you guys see why? That's the pattern. Now, to make it even better, I am coming from this direction. I could also come from this direction, right? So I could also do, so you guys are cool with this, 1, 1, and let's do 0.9, 0.81. If I do 0.9, 0.9 squared is 0.81. Is everybody kind of with me still? This is section 2.1. This is really all section 2.1 is. You create a table of slopes and you see the pattern to see if it looks like it's approaching something. So what do I get here? I get, I get 0.19 divided by 0.1, so I get 1.9. Sweet. And then if I use 1, 1, and 0.99, and whatever the shit that is, 181. Are you early? No, not yet. This is some kind of business. What's 0.99 squared? Somebody just do that for me. Tell me. Don't make me bust a synapse.
0.9801.
So then it would be 0.0199 divided by 0.01 is 1.99. So from both directions, as I get close to 1, from both directions, they agree that it looks like the slope is 2 right there. Craziness. Now, we start building ideas. Later, we're going to be able to get slopes really fast. This is going to be a stupid easy problem later in this course. Some of you guys have taken a little calculus already. I don't want to see any derivatives before we talk about them officially. So don't be, I got this homework. No, you don't. I'm going to redo it. Shit. We don't know derivatives yet? Some of you guys are like, what did you just say? If you know them, fantastic. Sit on them. You cannot use them at all until we officially talk about them in this class. Do you understand what I'm saying? There's something called L'Hopital's rule. What? What? I don't want to see that shit until we've talked about it in class. You guys with me? You do that, you're going to redo it. I mean, it's just silly. Okay. So section 2.1, they call it the tangent and velocity problems. If this was a time versus position, they use the letter S for position. If this was time versus position, what would the slope represent? Slope would be position over time, which is velocity. So then if this is my position function, if something is like here's Earth and this is some parabolic orbit comet, and I know the function of the position, I can figure out the velocity of the comet at any point as it goes. You guys kind of with me? It's a bad example if you think about it, but just go think about it. All right, maybe. Okay. One last thing, and then I'll let us out of here a tiny bit early. Section 2.1 is all about trying to find a tangent line slope at a point, and you just kind of step closer to that point. It's really not that crazy. Next time I'll pull up some animation stuff to show you. Today I don't want to waste your time trying to find it. The last thing before we go, I want to relate something to what we just did. What is the slope function from algebra again? How do you figure out the slope? y2. All right. What is y? Let's bring it. Y, of course, is f of x. So f of x2 minus f of x1 over x2 minus x1. Is that cool? Not a major step there, right? Y became f of x. Ooh. Right. This is now closer to calculus, though. What is f of x2? So let's do this. Let me do this. Let's make this a little more specific. Slope equals, so I'm going to have some other point, xy. Okay? So this will be f of x minus 1 over x minus 1. What is f of x? X squared. And I want to know the slope at x equal to 1, right? So what happens when I try to plug a 1 in here? 0 over 0, which is capturing the idea that we're trying to find a slope at a point. So a point minus a point equals 0 always. So it's going to freak out if I only have 1 point to input. You guys with me? That's capturing the idea of why we needed 2 points artificially, because I can't just do 1 point. The formula freaks out. But we have this idea that we just use today. What can I do algebraically to make this thing look different? Factor that. Factor x squared minus 1. X minus 1, x plus 1. What happens to the x minus 1s? Cancel. Where's the only place they don't cancel if x is 1? But what do? I get really close to 1. At 1, where is this? What's the answer? Holy shit, 2. Right? So this is the idea of the limits as x goes to 1. What this means is let x get really close to 1. And what did we actually do on the table? We let x get really close to 1. So this is kind of like the nitty-gritty, nuts and bolts, really detailed. This is, I'm going to let it get close to 1. This is the more precise algebraic manipulation. I don't have to do it by like guessing and checking. I can just do it by algebra. Factor the top. Cancel the problem. Now what happens to x plus 1 as you let x go to 1? Well, it becomes 2. So that jives with our observations. So limits are awesome because it allows me to do a lot of shit with this, because the idea of a limit is I never get to this number. I do not get to 1. I get infinitely close to 1. Really want this to make sense, because this expression equals this expression everywhere except exactly at 1. So whatever this expression wants to be at 1 is what this expression is going to get close to as x gets to 1. Freaky shit. So the first section is all about finding these slopes, letting your points get really close to the point you're curious about. And then the next several sections are going to be talking about the idea of limit. What does a limit mean? How can you use a limit? Visually, what's it mean? Okay, I like it. I think that's plenty for today. I'm sure you guys would agree. If anybody needs to see me coming up, I think. Does anybody need an ad code? Yes. Or if you need something else, just come up. Otherwise, I'll see you guys Thursday.
Is that a 2 square? That's the x plus 1 equals 2 for your limit? The one that you just wrote?
Two, yeah.
How did you get that?
When x gets really close to 1 for x plus 1,
Oh, so you just put whatever that is in
yeah.
for x.
The only time I can't put it in is if the inside becomes indeterminate, becomes like 0 over 0 or something. Yeah. There, see how this step I eliminated the problem.
Yeah.
So now I can just plug a 1 in. Yeah. Oh yeah, sweet. Oh yeah, you need an ad code.